And wait to see if it's streaming. As soon as I stopped streaming yesterday, I figured out what was the problem. Is that I had this thing here on this file, and so it was thinking for whatever reason that I was on the file solver folder. I think it has something to do with the way that the C sub process works. And then because of that, it created the files. When it worked, it created the files on the file solver directory. And then I commented that out and it worked. Oh, I forgot to post this stuff on TikTok. I'll do that later. So what I'm gonna do now, I still didn't get the sequence of floats from the dictionaries that I created. So I'm gonna do that now. And then I'm gonna think about a way to reverse engineer the algorithm to translate the dictionary into the sequence of numbers. I put here so I think I'll put this sequence on each file and then I'll think about it. And I'm gonna put music for myself only, I think. Yeah, I'm gonna spend 1.5 hours and then I take a break. And then after the break, or before the break, the first break, I will remove the camera. It's a lot easier to stream without the camera because it's more comfortable. And also it's better to think because you're more focused on the stuff that you're doing. So come here, 0. Now I'm gonna copy, open this file. I'm gonna have to create new ones probably. Whatever. I'm just gonna create the files first. Oh. I'm gonna delete the other ones and copy again because it's gonna be confusing. File formats. I was thinking maybe I could just do it with one. I don't need, with one file, I don't need a lot of them, because it might be just as simple as going over the list of numbers and then seeing what index it is, and then using that to search on the dictionary and get the values. So I think I'm gonna have to create another dictionary with the indexes, where the key is the card and the values is the index that it has to go into the list. I think I'll create another just to do this. Then I'll put them back again. It's easier to see. Obviously, since there's not a lot of files, I'm gonna do it manually, but then I could do a script if I wanted to do all the files. And what might be tricky is that it might change the order might change depending on what cards you have. But I think I can get away with doing always with the most complex formats, because then you just put 0 frequency on the ones that don't exist. Zero to 40. And so now I think I'm gonna create a different file. Just to create this script. Or I can remove this, all this stuff, but I think I'm gonna leave it here. I can put this stuff on our function and then create the other thing here. I think I'll do that. I'm gonna copy the thing to open the code to open the file. Oh, I did the folder on the pile, so yeah, I think I can't do like this maybe. I'm gonna open the other script to see. Wait, I think I don't want to print line by line, that's the thing. I just wanna get, so I think I'm just gonna print file. And print file. I should probably do this one first because it's the one that I'm curious about what's the format's gonna be. As it just loops through the file. So let me run this, see what happens. Yeah, so now is the part that I have to think on how I'm gonna do this stuff. It's gonna be a 0 here. Maybe I should do it like this, I think. Should open the two files at the same time. So the simple thing that I could do, I think, is just to loop over one of them and then make a condition to check on the dictionary for when the values are the same. It's probably overriding the built-in method, I think. Yeah. Now for value in as sequence. I think it's better to loop through the dictionary first. But I think I'm trying to think if there's a way to get the values only looping once, but I think it is not possible. I can use range, but then I'm not gonna get the information of the keys. And I think it doesn't matter that much, so I'm not gonna think about it too much. I think I'm just gonna do two for loops. Why is this? Oh, maybe because it's not a dictionary. It's a string. I wonder if I can do this. Maybe it works. Yeah, how I get the index though. So here it should be enumerate, I think. Not here. So this I think should work. The thing is that I'm trying to think about how to verify that it works. Like obviously, it's better if I create something that tells me the frequency first, I think, and then I will put the index, because it might be the case that it works on some of the dictionaries but doesn't work on the other values. And also, I think I need a way to. I'm gonna probably save this to a file if it works, the hands map, because it's better than doing this all the time. So I need a way to save the. Like I'm gonna save to a file and then I'm gonna just put on the script when I create the function to convert them. Because that way I have the mapping, then it's going to accept the dictionary and return the thing based on the index of the map. Return the numbers of the values. So maybe I'll initialize it as a dictionary first, and then how I'm gonna verify that. If it is 15, then it works. Let me think. So I'm getting the item and the key, which is the cards, and then I'm using that to create the key on the hands map, and the value is going to be the index of the bio sequence here. Oh, obviously the way that I can do it is just that later. So it treats this like a set because the indexes are numbers, I think. I think I'll put 0 here. I'm thinking about if it's better. No, it has to be the value, because otherwise I can't increase it. Oh, what I should do is just create the. I'm just gonna call this function and then save them on JSON format. Oh, the problem is that it's gonna be a different. It's gonna be different numbers. So maybe I can do this manually here. Oh, the thing is that it doesn't have the dictionary thing here. Or maybe it's just easier to figure out how to convert this into a dictionary. Or I can do it again. Because the thing is, I should have saved in JSON and text. I think I can just open and then open the file and then save in JSON format. That's what I'm gonna do. It's just easier. It's right. Let's see if this works. So it does write it as a string. But now I think I can just open. This doesn't work. So I can just split, I think, based on the comma. And then I convert this into a dictionary. Maybe I could do that with the text file as well. Obviously, I don't care that much about speed, I think. I can just, or optimizing this, just do whatever it works. So I can do a for loop and then convert. Yeah, there we go. But still incorrect. Oh, because it's just the string. Like it's just one item in the list. Or maybe not. So how come this doesn't work? Oh, because each one has the whole string, so that's not what I want to do. Yeah, I don't need the enumerate. And then I can just split this, I think. I have to do a bigger for loop, I think, on this one. Let's see if this works. Hmm. Because it's gonna be an array. Oh, it's because of the last one. I think the... Oh, but this way doesn't work because this one has this thing also. So I can just do a strip before, I think. Let's see if this works. I still have the... Oh, but now it works here, so all I have to do... I forgot how to slice the last element. I'm just gonna ask ChatGPT. Yeah. Or maybe I can just use pop. But I know you can use the slice notation with the square brackets and the dots. I think that would be better. I just forgot the correct way, because if you do -1, it's gonna reverse the list. There's -1 like this. No, that's not what I want. Oh, wait a minute. I think I'm confusing the... It's the last element of the sequence. So the things are... It's correct now. So the only problem is the last thing. Honestly, just thinking about saving JSON formats, just doing the thing, and saving on both text and JSON format in the first time, and then converting this stuff again. It's quite annoying. I can use I, but then I can split. There we go, finally. Now let me remember. The pi sequence is the sequence of numbers. The index is the place that they are. Or maybe it should be. Yeah, maybe the key should be the index on the map. And that should be the key from the dictionary. Oh. Yeah, I think it should be the other way around, because I have to test for the key, I think. Which is the value of the cards. So if the value is equal to the number, then I connect the cards with the index in this sequence. Oh, and that's what I was gonna do. I was gonna do a dictionary. To see how frequently they exist. Let's see if it works. So after I get this, I think I can check to see if the value of each one is 14, because it's starting from 0. Or 13, because there's 14 files. And if all of the values are 14, I can make a filter based on that. Yeah, make a filter based on if the values are different, and then check the length, I think. And if it is different, then it means that it was wrong. And so obviously there's something wrong here, but... Oh, because I'm making... No. I'm not making... But that's another problem, which... I have to check inside of the loop. And the thing is, once I get the sequence right, I just need to do this one time. Because I just need to get the mapping one time and then I can save to a file. And then I don't need to care about this code here anymore. So what is wrong here? And the only answer is that the item is not never equal to the number. Thinking about starting again and just saving on JSON, because this, it just increases the complexity. I think it's gonna be easier to just save directly on JSON, and then I can save the dictionary on JSON and then the text on the text file. And then I can forget about this part here. It just makes more complicated. Oh, maybe it's because it's a string as well. Maybe that's why it's not working. This I think is a number, but I'm gonna convert anyway. That's the problem. So it's getting the letters in the sequence, not the numbers, because it's a string. And so I have to split based on space, and then I think it's gonna work. But the issue here is that I have to print inside of the loop, because it's gonna mess up the values, I think. Or maybe not. Yeah, because each one is gonna be 0 in the beginning, and then after all of the iterations it should be 14, I think, or 13. And because each loop here, each thing here should just put the index one time. And then for each outer loop on the range here, it should increase by 1, because the key already exists. Hopefully it's gonna work. Like I said, I don't care about optimizing this stuff. Just gonna do this one time and then. And then for validating, I can create the ranges manually. I don't think I'm gonna create manually because it's better if I create with the code that I used here to create the cards. I just change instead of putting random number, I put a 1 here, depending on some condition of whatever combo I wanna make. 1. And then I can use the file that I save from this to verify if the function that I create is correct. I'll be right back while this solves. Oh, it didn't work. Maybe it did, but I'm just printing on the... But no. I think it didn't work because you would have the information there. Or it worked, but then the values are not. But that wouldn't make sense. Maybe because of this part. Because it needs to have the same value on the two different files, unless I'm using the wrong files at each iteration. So this loops over all of the items, and this loops over all the numbers. So it should, for each item, it should be matching with the number here in the sequence. Let's see if I'm getting through there. That's false. But most of them are going to be false. Oh, just do it here. It's going to be false, obviously. On all of them, otherwise I would be getting, I think, because I think this condition is not incorrect. Maybe if I put keys here, is better. So I think the only possible explanation is that, well, there's two explanations. One is that I'm getting the wrong file for each one, because of the way that I saved here. I think that's more likely. And the other is that there aren't two numbers, so it has to be... Oh, the other is that this code that I did here could be wrong. So I think I'm gonna do this again. It's probably better. Just erase this thing here from each one. And then I'll save both text and JSON. It's annoying because I have to do everything again. I think I will do only 10 files this time. I think it's unnecessary to do 14. Or 15. Yeah, 15 because I started from 0. And then I can get rid of the code that I did there. It's gonna be easier to see. Hate when it does that. Oh, the thing is that I'm translating to string here. So I think I can dump H because I want the dictionary. I'm just doing this to translate to a string, and the H is the dictionary that has. Oh yeah, because I'm putting them on here after I create the range, and then I'm looping to them, getting the items, translating to a string. I think this way is correct. So what's wrong now? This time is not the file there. Oh, not calling the function. There we go. And 391, 73. Yeah, I think it is correct. Now I'm gonna have to do the stuff again. I was translating each one by one. Hopefully this time it works. As if it doesn't, I'm gonna have to think a lot more about it, about different ways that I can catch the sequence. It should be all of them. And have them here and have them here. And now I'll go back to the other code. And here just open JSON file. I think I'll put this on the comments temporarily to see if I can print this stuff. Maybe JSON loads. I always forget which one it is, if it's loads or load. This range. Yeah, so now it seems like it's working. I'm just gonna remove this. And I think I can get rid of this stuff. Yeah, so now that I have the dictionary of the values. I have this sequence. Now let's see if it works now. If it doesn't work, then I think that's... The thing is, how can I verify if I have the correct thing there? Just look here. No, because if I look, then can I do Control F? That's a problem. So it doesn't convert directly. Maybe it's because of the amount of characters. That might be the thing here. So I'm gonna do the other way around. Now open this, and then how is this possible? Hmm. I don't understand like how, if there's obviously some translation that they do then. Maybe it's because of this. But it seems to me that the numbers would have to be... Oh, I think I get it. Like, it might be an issue because they are translating... Like, I'm getting the frequency for each combo like this. But then when it translates, it approximates the overall frequency, maybe? I have 0 here. This one. Let me put on another one. Like, I don't understand how is this possible. Yeah. Hmm. It doesn't make any sense to me because like they give you the information of how to build the thing. Like you need these numbers to build the scripts, and they give on the documentation like how the whole point of the interface is so you can build things with this. But then how, like, because in my mind, like, if they provide you the stuff, then it is for you to build things. But then you need these numbers to build it. So, like, that's why I feel like I'm missing something, because it doesn't make any sense. Because if you didn't know the sequence, or if you don't know the numbers, then how would you build anything? And then if you can't build anything, then what's the point of providing the interface? That's like, it doesn't make sense to me. So maybe I'm missing something. So obviously now the only thing I can think about is using the convolutional neural network or some other machine learning technique. But then obviously that's like not even sure, because the thing is I wouldn't need a big sample size to do that, probably, because I can just manipulate the data here and I can overfit. But that sounds like way too complicated just to figure this out. So there must be another way. But the problem is that I have to think now a lot on how I'm gonna figure this out. Like, I don't understand why it's not working though. Maybe it's just a approximation problem. And I think that's what's happening here. Is that because there's so many numbers, it's the exact match doesn't show up, but it is an approximation of the thing. So I think obviously what I can do is just test with like a range like this. But the thing is I need to specify the combos, I think. But here doesn't show the frequency. If I do, there we go. Oh, now it simplifies to. That's the other thing that is weird. Let me put 5 here. So I'm gonna copy this. Maybe that's what I should have done in the beginning. Because now it has the correct values there. Yeah, so what I'm gonna do is just use a normal, like a uniform distribution for each one instead of a random number. It's annoying because I have to do everything again, but hopefully it's gonna work. But then if it works, I'm gonna have to take that into consideration when I'm building the frequencies. There's probably something in Python that allows you to determine the precision of the things. I'm thinking about at which point it's probably better to create this. I think after here probably. And then like the thing is that I want to test with multiple different the size is gonna be float 16 or 32, I think. So it's probably based on that they pick the accuracy. But I don't wanna complicate too much. Because it's not obviously not that big of a deal if I create the range like with less cases. Like it doesn't even matter, like up to more than 2 I think is already, or even like broke down, because in practice it's not gonna matter that much, like all these small nuances of the frequencies, because it's not even accurate because it's always gonna be biased on the data and on everything. Like, so it's more of getting a very decent approximation and then like training your intuition. But then when you're playing, you're obviously not gonna be very precise with every decision on every frequency, because that's the thing about it, is always going to be subjective to some degree in poker. It's all these frequencies, how you're gonna keep track that like 2 years ago you made a bet on this position with this card, so you can maintain the frequency. You can use a randomizer when you're playing, but then obviously you're going to be biased as well. So it's pretty much impossible to keep track of the whole game and all the frequencies. So the whole point is just to train your intuition. So it doesn't really matter that much. The only thing that is going to be annoying and that I'm thinking about here now is that depending on how many cases, then I'm going to have to figure out for every script that I do to get when I'm getting the frequency for the data, how I'm going to round the numbers to a certain number so that it works here. So that's why I'm thinking about using more cases, so I don't have to think about this. Like, I want to see how much I can stretch this. And this is a different So I think then here I would increase by whatever amount I have there. 0.01. So that each file has, like, it's gonna be a uniform, every combo is gonna have this frequency, and then I'll test. I'm gonna put this, I think I'm gonna do less files as well. This is a waste of time to do that many. I think I'll do just one file. Like do one and then I test, and then if it works, then maybe I'll increase to make sure that that is working. Yeah, just making sure that everything's correct. Oh, I didn't call the function again. Oh, it's still everything. It's because it adds up, I think. But it should be just 0.01. Oh, I'm using the random number here. That's why. Now it should work. Yeah, there we go. So I think I'll test one at a time and I'll increase, because obviously I can create a program or something that is gonna allow me to see the boundary. I just want to see how far I can go with the squares here until it doesn't find anymore. Yeah, now obviously it's gonna find. So that's the thing. That's the problem. I need to create some broken down thing. It can't be just like a uniform number, I think. I forgot the word in English to talk about, to explain what I'm thinking. That's not a question. What do I wanna? How to determine? I wanna limit the amount of squares of the cases, however you say that. I think using the random number is better. I just have to limit the limit the precisions. Yeah, there we go. There we go. So it does work. There's just the number of. So I think I'll increase. I have an idea. I can just increase based on the number of the iterations. But it's very confusing for me, like why they don't explain this sequence there. Maybe it's just because they don't realize, like because they build the thing, so it's like intuitive for them. Or is something else that I'm missing, that there should be a standard or something like that to create matrices like this. I don't understand why not make it clear what is the sequence there. Like, it makes me feel that I'm doing something wrong with the way that I'm doing things now, where I shouldn't be creating the range with the dictionary here, but I don't think that's also not the case because I got the format from the text here. So what I'm gonna do is just create more files, and then at each file I'm gonna increase the number here. I'm gonna put I. So that way I'm gonna have a decent idea of when what is the boundary. It's annoying because I have to do this a bunch of times, but I think it's worth it. Then I think I'm gonna put a comment on the algorithm to say that the limit of the number of the precision is that number I find. So that I make sure that whenever I create a dictionary with the hand frequencies, that around each value to the limit, up to the limit. I'm thinking whether or not it's worth it to start with 0 here. So maybe I'll put I plus true. Let's run this. gonna test this and then I'm gonna take the break to eat something. And hopefully by today I'm gonna have the algorithm that transforms the dictionary into the sequence of numbers. I think if this works, it's probably gonna work if it finds the number on the file. I don't see why the algorithm would be wrong there. The only reason why it would be wrong is if the numbers don't exist on the two different files. Or that is the combo thing, where because there's a bunch of different frequencies of combos, it creates an approximation based on all of them. But I think that's not, it wouldn't make sense, because I think the sequence of numbers has to contain all the combos, and each value is the value of each combo. So I think the limit is when you have every single possible combo separately and a value for each, and it has to be the case, because then you wouldn't be able to build ranges with all the combos. So I think the limit has to be that for the sequence. So I think as long as you put a number for each one, even if it's 0, then it still works. And it would just get complicated if you wanna make one that is smaller, because then it is different. Okay, now I'm gonna translate all of this stuff again. Yeah, so this is 2, 3, a bunch. Be careful to not make a mistake here as well. Not copy the range on the wrong range on the wrong file. Now is the moment of truth. Let's see. I should test on both as well. Okay, now this one works. I think this is a problem as well, because ideally I would have more squares to differentiate, because if I have the same numbers, then how I'm gonna know what is the index? Like the same value for each for different combos. But the greater the thing, the easier it is to find it, I think. But if, like, after I find the limit, I can just think about an algorithm that is gonna make every single number unique, and then it doesn't matter. It just it shouldn't be hard, I think. Okay, so it works. I think I should just test from the last one. Cannot find. Yeah, this is weird to me. because it should allow way more. And so here's 19. So I think it's rounding the numbers, but why would you go from, it doesn't make sense. Huh. Maybe it's just a coincidence. Because it's... That's really weird. So it must be something with the combos. And the range has to be working, otherwise it wouldn't open the in-pile. Let's see if the file is cracked. Hmm. So what is going on? It has to be because of the different combos. Right here, it doesn't have the value. Because it approximates to 2. So it's just rounding the numbers, I think. Yeah, that's the thing. Let's here. So the limit is... I wouldn't expect the limit to be that low, I think. Just 2 numbers. It's not that is the limit, it's just that it's gonna round from that point. So now I'm thinking whether it's worth it to like do something that rounds the numbers, but I think it's not worth it. I think it's just better to just simplify and just do up to the decimal there. Because I'm gonna do this rounding after I got... So the way that I'm thinking about from the data is the way that I did the ranges that one time, where I just increase by integers the frequency that they exist, and I multiply by 100 divided by the total frequency. And then that will give a number between 0 and 1, I think. Then I might upscale the number based on the other stuff that I did. Or not. And then from that number I can round, I think, up to 2 decimals for each combo. And I think that's probably... like, it's just like I said, it doesn't matter that much because it's not gonna make a huge difference in the game. Like the whole point is just to get a better intuition, so you don't need to be extremely precise. Or I can think about a way to just round the numbers. Let's do show here. See if it was right. Yeah, then. No, it's 14. Nice. I cannot find 42. That is weird to me because you should be finding this here. So I don't understand what's going on. It doesn't work. That doesn't make any sense. Because how is it determining that this is this value here if the value that is not here? And it's just the value of one combo, so what am I missing here? It's here. I think most likely the way that these numbers work is just like you have a list with all the combos here and then a list with like with just one card. Like all ranks and suits on the direct x-axis and all suits and ranks on the y-axis as well. And then it just creates this matrix, which is all these numbers. But the problem is what order they are. I cannot find. So weird. So 6. Cannot find as well. Hmm. Yeah, I have to sit and think about, because now I'm questioning since it didn't get the number, like, because I thought it was rounding the numbers, but if it doesn't get a specific number, then it might be a different problem. That's the thing. It might not be a problem of the rounding, only the rounding might be something else as well. It has to be because here is showing this number and then here in the file doesn't show. So how does it go from this file to showing the number if the number doesn't exist here? That should be a combination of the other numbers. But it doesn't make sense. Like, why would it do that? It doesn't make sense in my mind. Maybe it's just approximation of the other, but then that wouldn't make any sense either. Because it would have to have... here is 1, so it's not the same. It's 14. Oh, maybe it's because the way that I'm doing this? No. That doesn't make any sense for me. What if I put this number and just save the range and see? 0, 4, 72. 0, 4, 0, 4, 2. One thing I can do is just use the... But this is... ridiculous, I think. It's so weird because now it works, it's fine, it finds here, but the other, unless I'm copying the wrong file, but I'm pretty sure I did the correct one. What I can do as well is just like after I get the mapping, then it doesn't matter. I just realized that it doesn't matter that much. Because once I understand how they're sequenced here, oh, that's the other thing I have to test though, is because I'm gonna have to do multiple different tasks. Because if I construct in this way, then it might be in one position here. But then if I construct another way, but then I think for that it's better to just test with the whole range all the time and just use 0 values on the other ones, and I think it's gonna work fine. I don't see why it wouldn't. But it's weird that it works here, but then when I have the full range there, it doesn't show. Like it's the same value, but it doesn't show. Like I have no idea why. It doesn't make any sense in my mind. There's something going on. The issue with doing with less decimals is that it becomes. I guess I can just do there so that I know that each one has a specific. I think that's probably the best way, so I don't spend too much time on this. But I am curious to try to figure out why it shows up here but it doesn't show there. It's very interesting to think about. But what I'm thinking about doing now is just create a unique number for each one, and then I just limit the number of cases. The thing is, I have to see. I probably won't be able to create a unique for each one because it doesn't fit. If I just use 2 decimal cases, there are too many combos. So some of them are going to be repeated. That's the problem. But I think if I randomize which ones are repeated, then I can figure out. But then it gets more complicated because of the way that I'm going to have to build the algorithm. Because I'm going to have to keep track of the numbers that I randomized to increase the index there, so I know that the frequency is compatible. It's annoying, I think. I don't want to do that. It doesn't make any sense to me. Let's check file. Or maybe it's because I'm copying this. Huh. Maybe that's the problem. But I think no. Maybe the way that you copy matter there. It might be that. I think that's the problem. Now it finds weird. Yeah, so it is the way that I was copying. Because I put with the combo and then it doesn't find. Yeah, it makes sense because then it's copying a different matrix. Yeah, I'm dumb. Just so many of them that it gets confusing. Yeah, so, but now I'm gonna do. Let me do the one that has the most characters to see. So maybe I made the same mistake with the other ones. I don't remember though. No, cannot find. So there is a problem with the accuracy, I think, as well. Let's do one in the middle, just say. Do binary search. Oh, so this finds. So maybe the 7. The 7. Let's make sure that I'm copying the right one. And so it still finds. I think I can trust that. It's very unlikely that there's the same number, so I could just put 0 as well. So it probably breaks down in the 9, but I'm gonna test 8 as well. Yeah, there we go. So it breaks down on the last one. And it's I plus 2, so it's gonna be 11, I think. But it only goes up to 8, I think. The iteration. So it's probably 10 decimal cases that it breaks down. 1, 2, 3, 4, 5, 6, 7. Yes, at 10 it breaks down. So I'm gonna write this down here. Somewhere. So did I do here? Yeah. So I'm just gonna delete this last one. And I think I can run the other algorithm now and it's gonna work. But I just need to do all of them. I think I'll do this after the breaks because I can do it one by one and I don't have to redo all of this. Oh, actually I'm gonna have, maybe not because I can leave it like this. Or maybe I'll do this again and then just do with the same precision for all of them. Because then it's less likely that there are gonna be 2 different numbers. I think that's what I'm gonna do. So just gonna run this again. And I'll do last files now. So I'm gonna do, let's do 6. Should be safe. And then here I'll do 4. I just moved there. Yeah, so I'll take a break, then when I come back, I'll convert this into file format again. And then I'll check to see if this part is working. Because now it should work, I think. Because the numbers... Yeah, I'm obviously gonna verify manually again. And then if it works, then I think there's no reason for this one to not work. And I'm using the JSON ones. And then I just need to run this once, or figure this out once I have the hash map, if it works. I have to think about how to verify, but I think I'm gonna verify once I build the function. But once I have the hash map, I can just hard code on the function. And then based on the input, I can construct the sequence of the floats based on the index with the map. It shouldn't be that hard, I think, if this works. So I'm gonna be right back. I'm gonna take the camera. Probably gonna stay for a longer time today, because I want to finish this out, and maybe I will start working on the other parts, because the other part is gonna be extremely hard, I think. The node locking part and creating the simulations. But I think what I'm gonna do first is filter the hands based on the board frequency, and then create some simulations, like automate the process of creating some simulations first, because then at least I'm gonna have something to train with, even if I don't do anything else. Like, yeah, I think I'm gonna automate from the river. So I'm gonna filter I'm gonna get the frequencies based on the river, and then build the simulations from the river with the data that I get from those rivers of the ranges. But it might not be enough, though. That's a problem. To build a range, an accurate range, but at least it's something. So yeah, I think that's what I'm gonna try to do first. Then once I finish that, then I can go and start working on everything again to make the other types of hands that have the whole cards exposed work, which is gonna be much better, I think. It's gonna allow me to have a lot more data, build the better ranges. But at that point, I think it shouldn't be that hard, I think, with the whole cards. At that point, it's more a question of thinking about what is the best way to structure the... there's also... I also have to play around with the node lock and the documentation from the node lock to see how I'm gonna build the ranges and automate the process of node locking the ranges at different parts of the game tree. That might be difficult, and creating the path for the node ID is gonna be difficult as well. So I think I want to figure all of this stuff out first and create functions for each one of them. Maybe not. Maybe it's better to just filter the hands on the different format first and then figure that out later. Because filtering the hands on the different formats easier. So, but it would be good to have the other one also, because then I can just remove that stuff out of my mind, so I can think about the other stuff. So, and then just have as much of the complicated stuff automated as fast as possible first. So then I can think more about how to structure the actual system of just getting the data and then creating the exploitations based on the ranges from the data, and creating the simulations to train with based on that. And I think there's also another problem, which is that probably the only way to train is with the flop simulations, because if you train from... I guess you can actually... like, the way you have to do it is just save all the rivers and then save all the turns, because if you have only up to the river saved, then it's not gonna... the simulation is not gonna be like from the flop to the river. That's the problem. It's just gonna play directly from the river. So that's another annoying thing, because then you have to create different packs, I think. And then on each pack you have to create a folder structure that contains the simulations from the flop to the river for each spot. Because that's the only way to node lock, I think. And to build the simulations with node lock strategies. Because otherwise you have to start from the flop, and then you can't... I guess you can node lock the flop, but not the other streets. And then save the node locked simulation and then use that from the flop. Yeah, but I'll think about all this stuff later. I'm gonna go grab something to eat and probably watch something while I do that. So I'll be right back.
Okay, let's do.
Alright, I'm starting my video series on how to create poker or a Texas poker GUI using tkinter and Python. I'll show you how it looks like. If I run it, this comes up. You enter in names. Right. Enter in the starting chips. Small blind, big blind. It'll deal cards. I have pictures of cards. I have the pot right here. This is all the tkinter GUI. This is 1,400 lines of code. So we're just going to start at the very beginning, maybe 5 minutes at a time. Every week I'll upload a video, and so let's see how far I can get and show you what I've done here. I'll also link a GitHub that'll have the finished code, so you can, if you want, just from the very beginning, just to open the code and run it yourself. But in this video series, I'm going to go through piece by piece and show you how this code works. So let's just start. We'll define main. If name is main, run main. I'm going to create a class called card. It's going to be an object. Define init. It's going to have a value and a suit. Self.value is going to equal value. Self.suit is going to equal suit. And that's it for now. Let's keep it simple. So you can understand what's going on. This is an object, a class object. It has a value and a suit. That's as simple as it gets for now. Let's create a standard deck. It's going to be a list, and it's going to be a list of cards, basically. I don't remember exactly why, but somehow along the process I needed to do super.init. If you don't know what that is, you can pause this video and go look for a YouTube video. There's a bunch of them that explain what super.init is. If there's something on here that you don't understand, I'm not going to take time here to explain it. So you can pause it, come back when you looked at a video that helped you understand it, and then we'll continue from there. So in the standard deck, I'm going to have a list called suits. It's going to be a list with a range of 4. The reason why I did that is because there are 4 suits. There's king, spades, hearts, and diamonds. And list range of 4 will be 0, 1, 2, and 3. And those values 0, 1, 2, and 3 we're going to assign to a suit. So 0 can be spades, 1 can be hearts, 2 can be clubs, and 3 can be diamonds. And we're going to do the same thing with values. Values is going to be a list of the range 13, because there are 12 values. It's going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace. Those are the 12 values. And here we have to make a list. We're going to first append a card object, which is going to have a value and a suit. And we're appending to self because self is standard deck, which is a list. So we can do that. We can do self.append card. And the way I wrote it here is for I in values, for j in suits, append card ij. What that does is it goes through a value, then goes through all the suits for that value, and then puts that in self as a card. And then goes to the next value, and then goes through all the suits, and then appends those cards to self, and then goes through all the values all the way to the end. And we should have 4 times 13 cards. If we put a calculator here, 4 times 13 is 52, the standard deck. So let's check that out, see what it looks like. So what I'm going to do here is I'm going to create an instance of a standard deck. Say deck equals standard deck. So what I did was I grabbed the class standard deck, created an instance called deck. Since standard deck is a list, we can treat deck as a list. We can say for card in deck, print card. See what happens. So as you can see, it printed 52 card objects. Each card object has its own memory location. And if we were somehow able to read these objects, we can't right now, but each card would have its own value with its own suit, ranging from 0 to 3 for suits, and then 0 to 12 4 values. So there's actually 13 values in 4 suits. And what this does is it's a list comprehension. If you don't know what a list comprehension is, you can again go on YouTube and look it up. Someone will explain it better than I can. Basically, we're iterating through values and then iterating through suits and giving that to the card object and then appending the card object to self, which is standard deck. So I'm going to leave this video right where it is right now, and we'll come back later and build on this.
Hello. Okay, let's do this. On the right side, you see the result of my code. I lost. Really? Okay, so I'm playing tic-tac-toe against a Monte Carlo search tree computer AI. For players, this is a human-like AI that makes good decisions by playing the odds. For developers, this is a fast algorithm that doesn't need to know much about your game, which makes it easy to use. If you want a copy of this code, you can find a link in the description below. If you want to learn how this code works, I will explain that right now. So this is the Monte Carlo search tree AI. It takes the current game state, and that could be the beginning or the middle of your game. It runs multiple random simulations. It makes random moves starting from your game state. Because it makes random moves, it doesn't need to know much about your game. Each simulation is evaluated with a score. A higher score means a better outcome for the AI. From each simulation, it only remembers the first move and score. Simulation scores are accumulated by move. After the simulations are done, it returns the next move with the highest score. And now I'll go over the code itself. So first, I import the random module and the AST module. I use the AST module to convert lists to text and back. I set the current tic-tac-toe player, either an X or an O. The number of simulations is very important. More simulations equals a more intelligent AI. I define the tic-tac-toe game board. And I set the starting player. I use this function to clone the main board for simulations. I check if the board has any moves left. A move requires an open spot on the board. Now I get the next move options for the current board state and player. This variable will hold all next move options. Each dot on the board is a move option. For each dot, copy the current board state. Mark that spot for the current player, and add this move to the list of next moves. And finally, return the list of next moves. This function checks if the current player has won in the current board state. A winning move is a row of X's or O's, depending on the player. Check each row for this winning move. Check each column for this winning move. And check each diagonal for this winning move. If no winning move is found on the board, return false. This function returns the next player. And now I retrieve the best next move. This variable stores each next move. For each move, it accumulates simulation scores. Now I run the simulations. Start with a copy of the current player and current board state. This variable stores all moves made in this simulation until the end of the simulation. I retrieve the next move option for the current state. The score value starts at the highest score. For each move in the simulation, I will subtract 1 from the score, so winning in less moves provides a higher score. Make moves until there are no more moves left. Pick a random move. Add this move to the list of simulation moves. Break the simulation loop if the player has won. Otherwise, subtract 1 from the score. Get the next player and move options for that player. Then, when the simulation is done, take the first and last move from the simulation. Turn the first move into a text, so it can be stored as a key in the evaluations. If the user has won, turn the score negative. That means that the AI has lost the game. Now add the move and score to the evaluations. Now all simulations are done. For each move and score in the evaluations, remember the move with the highest score. I use the AST function to convert the move back to a game state. And finally, I return the best move out of all evaluation scores. Now I use a simple function to print the board, and another simplified function to ask the player for the next move. I print the game board, and while the board has any moves left, if the current player is the user, ask the user for a move. If the current player is the AI, request the next move. Now I print the updated game board. If the player has won, print a congratulations message. Otherwise, switch to the next player. And that's it. Now I can play tic-tac-toe against a Monte Carlo search tree AI. For the simple game, the AI almost never loses. For bigger games with more decisions, the AI will be more flawed and realistic. So I will demonstrate one more time.
Hey everyone, it's Kalen from Kite, the AI-powered coding assistant. And today we're going to use Python to build an AI that can play the popular mobile game 2048. I like this game because it's simple yet challenging, and if you're anything like me, you'll find it harder to beat the game yourself than it is to build an AI to do it for you. To build an AI to beat 2048, we'll be using an approach called Monte Carlo tree search. Stick around to see how this is done and how well our AI does at 2048. Before we get started, we should do a little refresh of the rules of the game. 2048 is a strategy game of combining like values in a 4x4 grid, all of which are powers of 2, and we do this until we reach the value of 2048. The game begins with just 2 randomly placed tiles, and for each move, we slide all the tiles either up, down, left, or right. When the like values collide, they collapse into a single tile showing the sum of their values. After each move, a new tile is introduced to the 4x4 grid. The challenge is to reach 2048 before exhausting all of the slots in the 4x4 grid, and with no legal moves remaining. For a more detailed explanation of the rules, check out our video that explains how to build 2048 from scratch using Python. The link is in the description below. All right, first let's look at how the model works. We're going to use a Monte Carlo search tree to help us beat 2048. To understand this approach, let's think of the game as a decision tree. The root node is the starting position of the game, and the leaf nodes are the ending positions, classified as wins or losses. We want to find a path from the root node starting position to a winning leaf node and do it as fast as possible. This is a difficult task. Not only does it take hundreds of moves to win the game, but we are playing with imperfect information because new values will be added to the board at random each turn. To determine our move, we will evaluate a random selection of paths of our decision tree. This is where Monte Carlo comes in. Monte Carlo is a class of methods that model an event by generating a great number of simulations of that event and then randomly sampling outcomes from these simulations. So an example will help here. We can use the Monte Carlo method to estimate the value of pi. To do this, we generate 100 or 1,000 or 1,000,000 points within a unit circle. The more points we use, the closer we'll approximate pi. And for each of these points, we calculate its distance to the origin, and when that distance is less than 1, we color the point red, otherwise we color it blue. Now we take the ratio of the red points to the blue ones, and we'll notice that this value will be pretty close to 3.14. So hopefully that helps you understand how Monte Carlo methods work. The Monte Carlo approach we'll be using for creating an AI that plays 2048 is to generate a great number of games that end when either A, the game ends with a win or loss, or B, some move limit is reached. We'll call each of these games outcomes a path. We then score each of these paths based on the sum of the values of all the tiles that were merged during the gameplay. The paths are then grouped by their first move, and the first move with the best average score of its paths is selected. We are splitting our search paths by first move, so we will define a list holding the function for each first move, as well as a list for its respective score. This next portion of the code handles playing the first move. We'll loop over an index for each possible move and then try and play that move. Playing that function will return in the following order, and the board after the move was played, whether or not the move was actually playable, and the score from that move. If the move was played, then we will add a new tile in an empty square and add the score to the total scores we are tracking. If the move wasn't played, then we'll continue on to the next first move. Now let's look at the rest of the moves to be played in the search tree. From the position after the first move has been played, we are making a number of searches per move. We set the move number to 1 since only the first move has been played. We will also make a copy of our board after the first move and set a Boolean variable is valid to true. We are defining a while loop which keeps looping while the game is still valid and the move number is less than the search length. At each move, a random move out of the available moves is made. The random move function has 3 return values. They are the board with the move played, whether or not the position given to the function is valid, and the score for the move. If the game is valid then, the new tiles will be added. The score from that move will be added to the first move score's counter, and the move number will be incremented by 1. Then this just repeats until either the game becomes invalid, meaning there are no more playable moves, or we have reached the search length. The last step is outside of all the loops, which just defines an index of the move with the best score. Then that move and its validity is returned. If all the moves are invalid, then game valid will be false, and the given position wasn't valid in the first place. That's it. This bot should be able to play 2048 better than most humans now. But before we take a look at the results, I want to talk a little bit about Kite, the AI autocomplete we've been using in this video. Whether you're new to Python or already a pro, you should try out Kite as your autocomplete to reduce your keystrokes and save time programming. Kite is a free plugin for your code editor that uses machine learning to save you keystrokes while you're programming. So if you're using Atom, VS Code, Spider, PyCharm, Sublime, or Vim, Kite will seamlessly integrate into your coding workflow. Kite can complete entire lines of code, and it has a feature called intelligent snippets that will help you fill in arguments and method calls with variables defined earlier in your script. The window on the right side of my screen here is also a Kite feature called the Kite Copilot. It automatically shows you relevant Python documentation while you type based on your cursor location. This saves you time from having to Google search for docs. The best part of Kite is that it's free and you can download it from the link in the description below. Great, let's look at how we did in the game. We're testing our AI using 20 searches per move and a search length of 10 moves. The AI is displaying its moves on the board and the moves are printed in the terminal. If you've played 2048, you probably noticed the AI violates a lot of common human strategies to beat the game. For example, the tile with the largest value stays in the center of the board rather than in a corner. Even though our AI doesn't conform to human strategy, it's still successful and can be nearly guaranteed to win the game if the searches per move and search length are increased. Now let's speed up this video to see how it performs. Score, our AI managed to beat the game on the first try. So we've known for years that AIs are better than humans at playing chess, and today we prove that AIs are also beasts at playing 2048. So feel free to tinkle around with the code from this video today. There's a link in our description to the GitHub repo, and leave comments to let us know what you think. For more gaming with Python, subscribe to our channel now and ring that bell. We love bringing you fun and useful content that helps you code smarter, and we'll have more videos coming each week. Finally, don't forget, Kite's AI autocomplete helps you code faster and smarter. It's free to use, and the link is in the description below. Happy gaming.
Series.
Say we want to write a
last time
program
we
that can
implement-
play some turn-based game like chess. One aspect of this is the search algorithm, which is what allows the program to look ahead at possible future positions before deciding what move it wants to make in the current position. This white dot represents some position in our game with the white side to move. To keep things simple, let's say that in every position there are only two possible moves to choose between. We can visualize these moves as two separate branches, at the end of which are two new positions, where it's now, of course, black's turn to move. We can continue expanding the tree of moves until either we reach the end of the game, or we decide to stop because going deeper would take too much time. Either way, at the end of the tree we now need to perform a static evaluation on these final positions. A static evaluation just means trying to estimate how good the position is for one side without making any more moves. For example, a crude approach in chess would be to add up the values of the remaining white pieces and subtract from that the values of all the remaining black pieces. So large values would favor white, while small values would favor black. For this reason, white is always trying to maximize the evaluation, while black is trying to minimize it. So let's start with these two positions on the bottom left. Say we evaluate them and they come out as -1 and +3. Well, in the previous position it was white's turn to move, and since white will of course choose the move that leads to the highest evaluation, we can assign this position a value of 3 as well. Next, let's evaluate these two positions, and say we get +5 and +1. Once again, from the previous position, white would pick the move leading to the highest evaluation, and so we can assign it a value of 5. We've now evaluated both the positions stemming from this position, where it's black's turn to move. Black will choose the move that leads to the lowest evaluation, and so we can assign this position a value of 3. I'll very quickly step through the other half of the tree. Say we evaluate these as -6 and -4, white will pick the -4. The next two positions are evaluated as 0 and 9, so white will pick the 9, and between -4 and 9, black will pick -4. At last we've arrived at the top of the tree, where we can see that white should choose the move on the left, since that way, even if black plays the best move, white will still get a +3 position. So now that the basic idea is hopefully clear, let's look at how this is implemented in code. We have a function called minimax, which takes in the current position position, a depth for how many moves ahead we want to search, and a bool called maximizing player. We begin by checking if depth is equal to 0 or if the game is over in the current position, in which case we return the static evaluation of that position. Otherwise, if it's currently the turn of the maximizing player, which in our example means it's white to move, then we want to find the highest evaluation that can be obtained from this position. So we create a variable called maxEvaluation and initialize that to -infinity. We then loop through all the children of the current position, and by children I just mean the positions that can be reached in a single move. To find the evaluation of each child, we make a recursive call to the minimax function, passing in the child, depth -1, and false, since it will now be the other player's turn to move. We can then set maxEval equal to whichever is greater between the current max evaluation and the evaluation of the child position. Once we've evaluated all the children, we can return the maximum evaluation that we've found. Now, we do essentially the same thing for the minimizing player, creating minEval set initially to +infinity, and for each child position we call minimax, passing in the child, depth -1, and this time true. MinEval then gets set to whichever is smaller between the current minimum evaluation and the child evaluation, and finally we return the min evaluation. Let's step through this example again, this time with the code in front of us. First though, we'll need an initial call to the minimax algorithm to start things off. Okay, we're at the first position and we want to find the max of the two children, so we call minimax on the first child. It wants to find the min of its two children, so it calls minimax on its first child, which in turn wants to find the max of its two children, so it calls minimax on the first. At this point though, depth is equal to 0, so minimax returns the static evaluation of that position. This value gets passed up to the parent, which then calls minimax on its second child, receives the static evaluation from that, and returns the max between the two children. That value gets passed up to its parent, which now calls minimax on its second child. Minimax is called on its two children, getting their static evaluations, and the max is passed up to the parent, which passes the min of its two children up to its parent, which now calls minimax on its second child. I'll stop with the blow-by-blow narration now, but hopefully it's quite clear how the algorithm uses recursion to search through the tree. Now that we've seen how plain minimax works, let's run through this example yet again to look at how it can be sped up using pruning. These first few steps are the same as before, but consider the situation we have after evaluating this +5 position. Without yet evaluating the other position, we know that white can at least get a 5 from here, so we can mark this position as being greater than or equal to 5. We can now see that black won't go down this branch because he already has a better option available. This observation means that we don't have to waste any computation on evaluating this final position. We can simply pretend it doesn't exist. In other words, we've pruned it from the tree. Things now continue as normal again for a few steps until we get here. Black to play in this position will be choosing whichever of the two moves leads to the lowest evaluation, so we know the evaluation here is going to be less than or equal to -4. We can now be sure that white won't go down this branch because he already has a better option available to him, and so we can prune these positions. As you can see, the result of the search is exactly the same as before. We've just saved some time by not considering positions when they can't affect the outcome. Okay, I want to quickly go through a slightly deeper tree. I'll just fly through these first few steps because there's no pruning happening, so it's quite straightforward. In fact, it is actually kind of interesting that we've gone through half the tree and haven't been able to prune a single position yet. So pruning isn't guaranteed to occur. It very much depends on what order the moves are in. Ideally, the moves would be ordered from best to worst for the player whose turn it is in that position. For example, if these two moves had been the other way around, we would have been able to prune the second one. For this reason, it's usually a good idea to order the moves based on how likely they are to be good. For example, in chess, capturing a piece with a pawn is very likely to be a good move, and so it would be wise to explore it first. Anyway, let's continue with this tree. So this next position has been evaluated as +1, and now I have a question. Do we need to evaluate the other position here, or can we prune it? If you're in the mood, I'd recommend pausing the video to figure this one out. So without evaluating the other position, we can say for sure that the previous position is less than or equal to 1, since black is of course just going to choose whichever is lowest. This means that white will never go down this particular branch, because if the best he can hope for is a +1, he'd rather just go the other way at the start, where he's guaranteed a +3. So we can indeed prune that position. Alright, let's finish off this tree. Here we got a 5 and a 2, so black would of course choose the 2. That means this position is less than or equal to 2, and so like before, white will never go down this branch since he can get a 3 by going the other way. This means that we can prune the rest of these positions. The tree is now complete, and we can see that with best play from both sides, the game will follow this path. Let's look at how this pruning stuff works in code. We'll start with our original Minimax algorithm and add 2 parameters called alpha and beta, which will essentially be keeping track of the best score either side can achieve, assuming best play from the opponent. We'll need to update our recursive calls to Minimax to pass in these 2 new values. Now, for the maximizing player, we'll set alpha to whichever is greater between alpha and the latest evaluation. Then, if beta is less than or equal to alpha, we'll break out of the loop. Similarly, for the minimizing player, we'll set beta equal to whichever is smaller between beta and the latest evaluation, and then once again, if beta is less than or equal to alpha, we'll break out of the loop. To better understand what's going on, let's step through the example one last time. In our initial call to Minimax, we'll pass in -infinity, which is the worst possible score for white, as our value for alpha, and +infinity, the worst possible score for black, as the value for beta. These values get passed down until we reach our first end position. Here, -1 is greater than alpha, so the alpha value of the parent gets set to -1. 3 is then greater than -1, so the alpha value gets updated once again. However, beta is not less than alpha here, so no pruning occurs. Next, in the parent position, beta gets set to 3, and this is passed down to its second child. After evaluating this +5 position, alpha gets set to +5, and now beta is less than alpha. Since in this position it's white to move, beta being less than alpha means that black had a better option available earlier on in the tree, and so we prune. Going back up the tree, alpha gets set to 3 in the first position, so we know white is guaranteed at least a 3, but we need to explore the other side of the tree to see if he can do better than that. So coming down here, neither -6 nor -4 are better options for white, so alpha doesn't change. In the parent position, beta now gets set to -4, which is less than alpha. Since this position is black to move, beta being less than alpha means that white had a better option available earlier on in the tree, and so once again we can prune. We've now completed the tree. So hopefully this video has made sense of the Minimax algorithm and how it can be sped up using this idea of pruning any branches that can't affect the outcome due to the fact that one side will prevent that branch from ever being reached, as they have a better option available earlier in the tree. I'll leave you with the last few moves of this game, which
recommended this quiescence search for our alpha-beta algorithm, and we also discussed that maybe we want to write some front-end, it would be nice, but I thought maybe it's better to stay on track what the initial idea was and then do the front-end all the way at the end. So last time I already mentioned this article, General Game Playing with Monte Carlo Tree Search by Michael Liu. Feel free to read it, it's pretty good. It explains how Monte Carlo Search works with its different stages. So first you have a selection stage where you basically expand nodes in a tree until you reach a node where you haven't done any further next steps. So initially you just start with the root node, then you pick some of the next steps, which would be, okay, we're in the root node, let's say this is all our tree, then we cannot go down any further. We pick one of the next nodes, which is called expansion. So in our case, from the root node, we would then pick this one. Then we do some simulation, which is basically do random moves until you reach the end of the game, X times. Here it says one simulated game is played, but you can also play more than one. And then you propagate the result of the simulation back all the way to the root, and then you start from the beginning, which would be, okay, now we already expanded this node, so we can either go down here and pick another of the child nodes, and then do expansion again, which means add it to our tree, simulate until the end, propagate, go back, go down again. This time you might pick the middle node, add it to the tree, simulate, back propagate, and so on and so forth. And then the way you determine which is the best move is like according to this formula. Yeah, backpropagation. It's explained in this blog post. It's pretty good. Then also at the end he has a JavaScript implementation. If you're interested, he said this is heavily influenced by the other article, which I also want to cite here. So this is by Jeff Bradbury, written in 2015, Monte Carlo Tree Search, where he also explains the same concepts and also has a Python implementation. I'm gonna more or less, I don't want to say copy, but we're gonna re-implement it the same way that he does. I will try to actually check the methods that he has and basically implement the concepts myself, but like, you know, take a look at what he's doing, not spend too much time debugging my own stuff. So he needs a board which has a start, returns a representation of the starting state of the game. He needs current player, next state, legal plays, and winner. I think we kind of already have this. Then he has a Monte Carlo class which takes an init, update, get play, and run simulation. And then he gets past the board, we will not have this in our init. So if we look at what we have in our alpha beta search, we have a method get best move time and get best move depth. We will probably just copy those two. And I already made a file called mcts, Monte Carlo tree search. Tree search. I think we don't need this in Python 3, and then we paste our two methods. And this one doesn't apply anymore. But time, okay. What we want here, we want to div init self states is empty, and I actually, yeah, I will copy this later. So we will pass the board in the get best move time method, and we will update the stage. I don't think we need a separate function for this actually. The next thing he actually implements is a function called getPlay, or he starts implementing the function getPlay from which will calculate the best move, and it will basically run simulations until the time is over. So we do something similar. We import time while allow time.
Alright, let's continue. I'm gonna spend another hour. I was thinking about a bunch of different stuff, so I might stop after this 1 hour to do some things off stream. But where was I? I think I was converting the ranges. Yeah, here. I'll keep doing that. I need to create the file. Hopefully, I want to be able to finish this in this hour that I have. If I do, then I might stop and leave the other stuff for tomorrow. I think I'm also gonna play a lot more hands, so I have enough data and I can focus on the other parts, on the other format of the data. So I have some data of the whole cards. I think that's gonna be a lot better. And then from that point, like, I think once I finish this process of creating at least a few simulations, then I'm gonna spend a lot more time. I might go back to doing videos for the other channel or writing articles for the blog while I play a bunch of different hands, so I can get more data to do the other format. And it's also kind of annoying to eat while I stream because it takes a long time. So I think for the video it's just a bunch of empty time. So I don't know. I think next time's what I might do, because the issue is that once I stop streaming, it's kind of annoying to go back and like stream twice in the same day, because there is momentum. At least I work like that. Like once I start doing something, I get very fixated on that thing. So it breaks the momentum when I stop the stream, because then I start focusing on other stuff. And then it becomes hard to go back and to stream. But I think what I might just start streaming twice when I want to do things like this, where I'm gonna stay a long time. So just break the stream on when I have lunch, and then come back and start streaming again after I eat. The issue is that the current way that I'm doing a diet, I have to eat 6 meals, I think, a day. So it's a bunch, and I think I might change that as well. So eating less times in a day, which is worst because, well, I think there's different philosophies, but from one perspective, and I think that's intuitive and makes sense, it's worse because you're not absorbing the nutrients as well if you eat too much at once. So it's better to space out the eatings, so that you absorb everything better. So I think this time I'm gonna test here first. I should test probably like this, because those are the files that I'm gonna be using. So here, and this one works. Works as well. I think all of them are gonna work now. Just want to make sure, and then I will run the script. Yeah, there we go. So let's run this. So let me recap what I did here. I'm getting the sequence here, the dictionary from the JSON file. Then I loop over the key and items. Then I loop over the sequence and get the index. And I transform this into a list. And then I check to see if the float of the number is equal to the float of the item in the dictionary. And then if it is, and the key is not on the map already, I create the key equals to an object with the index 0. And then the other times I increase the index to see if it's getting the correct one on all of the files. So I think that this is correct. So let's run, and hopefully it works this time. Let's see, and ranges. Oh, it's because I changed the name of the file. It's file format and then file now, I think. Let's see here. It's the other way around. Also, it is hitting this at least. So I think it fails on the other sequence. Now let me think about this. Also, this is happening because the index doesn't exist, but the key exists. So it should be testing the index on the other. Let me think about this. How is it possible that the key exists and the index doesn't? Because if the key is on the hash map, the index should exist, I think. Unless there is an error in the sequence, like the same number twice on different situations. As the key is the value of the cards. Or is that situation that I talked about where you have two numbers that are the same? For different cards. But if it's sitting this line, it should have the key on the dictionary anyway. Now let me think. Is the key is on the dictionary, but the index in the sequence is not. So that has to be wrong because unless the numbers are equal at some point, and then it puts that key on the map. Like there's two different situations where this is true. And then it puts the key on the map, but then the index is gonna be different on another time. And the key is already on the map because the numbers are equal. Maybe. That's what's going on, I think. Let's see. I can do the other way around as well, where I do the index here and then I put there. But then the concern that I have is that I'm doing the thing like in the incorrect way. Like even though it might work if I run, that the sequence for whatever reason is not correct. The mapping is not correct. But I think that's not a huge deal because I can just test later once I have the function. Okay, I can generate a bunch of dictionaries, pass through the function to get a bunch of different bio things and see if it is the same or not. Yeah, the only annoying thing is that I can't open directly with the PIO sequence on here. So I think I would have to manually test anyway, at least some of them. Because I can't test the PIO sequence. Yeah, but I think I can just do that, it's easier. So let me run this again, see if it works like this. Let me erase this stuff from here. King diamonds and queen of diamonds. Yeah, now I don't understand. Maybe it's because of the way that I'm doing the loop. And for each key and each item is gonna go over this sequence, the entire sequence. And then it's gonna check at which position is the number. And then based on that, it creates, if the index is not on the keys, it creates the value of the key as this dictionary that contains the key. And 0 as the value. And the key is the value of the cards. Oh, it's because on the outer loop I think is incorrect, but that wouldn't be possible because for this to be complete it has to have all of the keys. Because it has to go over all of the the sequence here. So I have to go over all of the combos. That's what I don't understand. So to make it easier, I'm just gonna print I each time here to see in what I think is the first sequence. Oh, second sequence. Third one. I thought it was the. Okay, so he's working on the previous ones. So 0, 1, 2. Let's see if works here. And get this value that is. Yeah, now I should run again with the value. And then I'm gonna be able to. Cannot find. What the fuck? Oh, this is Pio1. The wrong file. But either way, because it was the I was equal to 2 there. Oh, so maybe it's Pio because it starts at 0 to 0, but it has to be the same because the index zeros are the same. So let me open again. This true. This true. Oh, now so I opened the wrong file there. Cannot find. How is this possible? So it's the wrong range I have here. And it's so confusing. What? What's going on? Oh, it's because yeah. So there's two is because I'm going down here. So there's two values. That's what I was suspecting. If I go up, yeah, there we go. And it's just because of the way that these things work. So the issue is when there's two values that are the same, which is what I was suspecting. But now I have to think more to figure out. Because the index already. Oh, but. Yeah, because the index exists because of the other iterations on the outer loop. That's why. So it checks this condition and goes here, but the key doesn't exist. But that wouldn't make sense because like it has to go over all of them. This is what I don't understand. Or maybe it's just the way that I'm accessing here. Let me print Hans map here. Sure. with music from myself. I don't understand. Like, I understand that I'm not checking both. That's why it's wrong here. Because the key doesn't exist when it reaches the point, but the index does because of the outer loop there. But the issue here is that you should have the combo for the other ranges. It doesn't make sense that you wouldn't have, because the way that I built them. So when it goes through this, through the keys, what if I put the other way around? What's gonna be the issue? At least the rest, it seems to be working. Like, because all of them have the same index. And it is getting all of them. And so here, it gives me 303. Maybe it's because it's the wrong mapping. That's the thing. I think I'm just trying to make sense in my head, but I think I understand. I'm just trying to clarify so I can solve the issue. I don't want to just put the check here for both of them, because then it might still be wrong. I want to make sure that it is correct the way that I'm thinking about it. So let's see what happens. So if I have a key and an item, and the numbers are the same, so it's going to store the key. Because this is the part that I don't understand. Oh, it's because for that key, the index is different. That's why. So it's trying to create two different... Because the key exists, but the value of the index is different. Yeah, that's what's going on. Because there's two numbers that are the same on different positions. So maybe I can just... I think it doesn't matter. I can just do a try except block, because it doesn't matter. Because as long as there is enough iterations so that at least one of them exists. Oh, but then how... And the question is, how do I verify the other positions based on that one? I guess I can create a new key. Like, I can check for both and then create the thing, and then I can make other conditions here to specify the situation where there's more than one key for the thing, or one index for the key, because then I can go with the one that has the highest value, because that one was the one that the position that it was at, the thing was at in the position of the sequence of the numbers. So let's say you have a situation, it's kind of confusing to explain. But let's say you have this situation where you have, whatever. Where you have the same number here and then the same number here, for example. So it's gonna save the key for this value as this index here. But then once it reaches this point, it can't find the index, because it's now is looking at a different index, so that this value here doesn't exist. So what I'm thinking about doing is just creating a new index here for this key. So essentially just putting the second index here once this happens, and then making equal to 0, and then after enough iterations, the one that has the highest value is the one that is the correct one, because it was the one that had this. It was in the same position on the previous files. Like, it was on the same position for the most amount of files, of different files. So the question is, how do I make the condition here so that it does that? So I think I can do, yeah, just index not in this value here. Then I initialize to 0. And then else I increase by 1. But the only downside of this is that at the end I'm gonna have to think about but I can just loop over I can do the same loop that I did here, and then just get the value and compare which one is the greatest one, and then create a new dictionary with only the values of the indexes, and then discard this one. I think that's what I'm gonna do. This plus equals 1. So hopefully now it's gonna work. Yeah, so I think it worked now. So if the key is not here, then it creates the thing from 0. If the index doesn't exist, it's because there's 2 different indexes. So we initialize the second one as 0. And otherwise, I just increase the current one. And then the one that has the highest value is the one that is most likely to be the correct position. So now what I have to do is, first I'm gonna loop over this, and then I'm gonna see, I think I just use key value because I don't want to think about the names. I'm just gonna see, so the key is gonna be the dictionary. So if length of key dot keys is greater than or equal to 2, then I print the key and the value. Let's see if it works. Oh, it's a string. Oh, because yeah, I'm getting the values actually. The values are gonna be the keys, the cards. Okay, so yeah. Yeah, so there are these situations where it is the same index, but then you can clearly see that this is the winner. And the other ones are changed, because it's the one that has most numbers. It's not that it's changed, it's that it's the same number for both of them. So yeah, and you can see that it's switched here. And then here is switched as well. So it's the same number for both of them, that's why. So I think that I'm very confident that this is correct. So the value is going to be the dictionary, and so the key of the value, or maybe I should have done the other way around so it's easier to get the key. Because I just want the key out of this value here, which is the index of the sequence in pile for the card. And I think I'm gonna save the final mapping, I'm gonna save to the dictionary, then I just hard code on the function. And then I'm gonna encapsulate this on the function. I think I'm gonna delete this stuff here, because I might need it in the future. Yeah, so the key is gonna be the card. The key is gonna be the card, and the value is gonna be the index. Now the question is, how do I get the think I'm gonna get here, and then how do I get only the key? I can use dot keys and get the first index. I think that's the easiest way. Oh no, but then once it has true, I have to filter. So because I need to get the one that has the highest index. It's kind of annoying. I'm thinking whether I change here to make it easier, or if I just maybe use ChatGPT to get the one. So much time I have. I think I'm gonna be able to do it in the rest of the time that I have here. I think I'll be right back. And so I have to think about an algorithm. I think I would just do it the simplest way that I can possibly think. Just loop over the keys, or loop over the dictionary again. It's annoying because I can't really do the max of both of them. I think I might not be able to use ChatGPT now because it's on the that everyone is using, so let me think. What is the easiest way to... I want to get only the key from the value that is the highest. It would be a lot easier if I had the other way around, I think. I think it's the same thing. I can do something to sort the dictionary and then get the first. Don't like that. How do I separate? Because once I have the max value, how do I use that to get the key? I think I have to cache the index. So I've done this loop, I think, a bunch of times where you create a variable there in the beginning and then you use that variable to loop. If item greater than v equals item. And then I make... I think it has to be outside here. I'm gonna make the whatever value equals to the index here, because it's gonna be the equivalent. So let's say the item is 3, then it's gonna become v. So v is gonna be the maximum out of this. And once that happens, I want to get the index, which is the value that I want, and store in the variable. I think it's gonna be... I'm trying to think about a name. Obviously, it doesn't matter that much because I'm not gonna keep this code, I think. Maybe I will actually, in case I want to use it in the future. So what is a good name to put here? Well, let me remember. So the key is the cards. Cards. And the value is the bio index. I think this is easier to understand. Then the item is the frequency, and the index is the... Maybe spio mapping is better. Yeah, now it's much better, I think, to understand. Card index, I think. You just put 0. Yeah, there we go. Oh, actually, yeah, it has to be equal. Because in the first iteration, like all of them are gonna be 0. But I guess they're gonna all be greater than 0. Because they're more than one file. But I think it's better to just leave equal there. Just to be safe. And then this is gonna become this index here, I think. So card index. And then I don't need to check, I think. Now let's see if this works. Yeah, it doesn't work. Hmm. A pile map is gonna be this dictionary. The frequency is gonna be the tree. Pile index is gonna be the card index. I don't understand why this is not working. Oh wait, I have to change this. That's why. Yeah, because this is a global name, that's why it didn't give me any warning. I think. Yeah, so if cards not here. Now it should work, I think. Let's see. Yeah, there we go. Nice. Yeah, so now I'm gonna save this to a file. I'm not sure if it's right or not, obviously. I don't know if it contains all the indexes. But whatever, I'm gonna save this to a file and then I'm gonna use that to create the function that converts and then I test the function. That should be JSON as well. And did it work? So now let's see. What do I do? Maybe just copy instead of open the file. I'm gonna do like this first. So yeah, I think I need this create cards again. But instead of saving here, I can just, yeah, I can create other files. I think I'm gonna, just so it's easier, I'm going to create another folder here. And then I'm gonna put these ones here. And then I'm just gonna run this again to create other files so I can test. Yeah, the thing is I have to delete this, then I create the files. Then I pass them files through here. And then I get the Pio version and then I compare to see if they are the same. Because I can't test the Pio format directly there. I can also do another function to convert the other way around using the mapping. And then I can use that to... So I can do both ways, but it's just a matter of testing, I think. It shouldn't be difficult. So I'm gonna run this again, I'm commenting this. And I think I'm not gonna leave them here, I'm just gonna pass them here. And then delete these ones. Oh, actually I need to keep them there. So I can convert. And I should keep the JSON as well. Maybe I'll leave the JSON formats. I have a bunch of shits there, so I'm gonna run this again. I think I'll pass the text files there, and I'll leave the JSON ones here. So what am I trying to do? So I have the mapping. I have to think about how to use the mapping to translate. We just print here. It's complaining. It's gonna be a string if I read. It has to be JSON loads, actually. And maybe I don't even need to convert. Alright. Let's try this. Okay. So let's think. So I wanna do the loop here again. Where are we? In range 4. And I'll open this. Yeah, so now I have to think how to use the index to convert. I think I have to order the dictionary first. I can use the function that I used on the other one. So order the hand mapping first. And then update the values. Well, it's kind of confusing. What I want to do is create a string, I think. I have to think about what format I'm gonna use in the end. I think it's gonna be a string because I wanna write the string to a file, maybe. Maybe I don't need to write it to a file. I can just use the string to set the command directly. Yeah, but I think the function is gonna return the string with the mapping. There's gonna be a pile hands, and it's gonna be like this. So for each position, I need to add it with a space at the end, and then I just write strip at the end. So the dictionary contains the combo and the value, the frequency. And the mapping contains combo, index, string. Yeah, so I need to sort the mapping first. Let's see how I did that on the other one. Just gonna copy this stuff. It's not gonna be reversed. Yeah, I think now it works. And then I just loop over this because now it's on the correct index. So I just need the keys, I think. But obviously it's better, easier to just loop. Then I just add to the hands. I use the combo in the dictionary and add. Let me think. Dictionary combo with a space. I think that comma is not needed. Yeah, so I'm getting based on the combo here because it's in the order, correct order already. I'm getting on the dictionary the value that it is, and then I'm putting on this string, and then the pio string is gonna be. Then obviously I need to. I think I need to initialize this at the beginning here. But on the function, I think I'm just gonna hard code the. Like the dictionary is gonna be in the input in the function, and the other thing is gonna be hard coded. This mapping here, maybe, yeah. I can just save this directly, the sorted thing. Then I don't need to do this thing here as well. Let me run this first. See if it works. Because the issue is that I don't know if it is gonna work at the end. When I convert, I have to test. So that's why I don't know if it's worth to save like this yet. But now I think the hard part is already done, because now it's just a matter of dealing with these small things. So I think it's safe to say that by today I'm gonna have this already. And I was thinking about creating the scripts is not gonna be that difficult, I think, as well. And the most difficult part is node locking, but to create the simple scripts is just, all I have to do is like make the templates of the script on a file, or I can just write the actual strings and then just put the square brackets here on the parts that are going to change depending on the data. I think the bats are always going to be the same. And then I'm going to have to separate the different bats based on whether or not I'm in position or out of position, and what kind of a hand it is, for if it's 3 bats or single spot. And then those parts I can just use. Yeah, I can use different files to load the commands from those parts. So I think it's working. Nice. Now I have to test. So I have to save this to a file, I think. It's very confusing because there's a lot of things going on. Yeah, so all I have to do is save this to a text file. I need to strip in the end as well, so that it removes the last space of this string here. Yeah, so I'll open another file here, and then I save, I think. Just gonna copy the. And the converter is the one that has the mapping. Yeah. Which I think what I'm gonna do is just save this sorted mapping instead, if it works. Because then it's obviously easier. I can just hard code the thing. I always forget if I can write the file directly, but I think I can. If I just file that right. And hands. And then here I'm gonna create another folder, I think. Let's see how much time I have. We're almost there. Yeah, I think, like, because I'm probably gonna stop after this, because all I have to do is just just clean this up and then do it. But the biggest part is already done, I think. And I think I'm gonna solve some stuff off stream and I might come back, but probably not. Yeah, so now all I have to do is, I think I'm gonna create a different file for this, but loop over these files, get these strings, and then compare with the strings that I get from these ones. So I think I'm gonna create a different name here. Task 0, task 1, 2, 3, and so on. And then I'm gonna copy this stuff that I get from directly from Pio into this and compare both of them. Hopefully it works. This is 0. Compile format. Yeah, now I think I can't compare directly. Oh, maybe I do. Yes, it's exactly the same. You can already see here. That is correct. Nice. But I can also, I think I'm not gonna bother creating the script because I can visually see here that is exactly the same. So it works. Nice. So now all I have to do is save the hard-coded version of this thing here. I just save this to a file and then get it, copy straight from the file and put it on the function. So I'm gonna clean this up. We're gonna create a function out of this, format everything. And then the next step is just creating a simple, which I might do on stream as well once I have cleaned everything up. Which is just gonna be, I'm just gonna put all the lines that are equivalent to each bat here that I have. So like remember that I saved here the standard bats. So I'm gonna open these files and then I'm just gonna get this portion of the bat sizes here. And I'm gonna put each one into a file, and then I'm gonna make a function that it depends on, that I can pass as an argument whether I'm in position or out of position, and what kind of board, what kind of hand type it is, if it's a 3-bet or a single spot. Then depending on these parameters, I open the different files with the bats, and then I also make the function dependent on the board type that I pass as a parameter. And then on this part as well, after this part I just put the converted range as another parameter for the function, and also all the stuff that is going to change for each hand. And then I can change this stuff based on the data that I get. And what I'm probably going to do now is just create the simple simulations based on the river. I'm going to sort the data based on the boards that happen most often from the river. And I'm going to try to get the ranges from them, from both my position and their position, and use the standard bat sizes here. And then build the simulations programmatically with Pile. Now, once I have that saved, that I can train with, I'm going to test, obviously, to see if I can add them on, but I think I can add them on GTL Trainer here. And after I do that, then I think I'll go back to the beginning and start formatting the other hand type that has the whole cards exposed. And then I would think more about the node locking parts and all of the other stuff that is going to be extremely hard, I think. But, yeah. but it's also the more interesting stuff, I think. So I think I'm gonna stop here, and I'm gonna do this stuff off stream of rewriting everything, and I might come back today, but maybe not. I'm not really sure. Depending on the other stuff that I'm gonna do off stream as well. So, but I do want to make this part here on stream. To build because I think like it is important, and since I already have a lot of videos building this stuff, like I kind of have to include this, I think. But I might leave to do this for tomorrow, so yeah. So if I don't come back today, I'm probably gonna come back tomorrow.